Sim, é o que vamos saber, compartilhando aqui e agora as matérias sobre o tema.
Last October, astronomers made a spectacular discovery. For the very first time, they spotted an object visiting our solar system from outer space. It set off a hurricane of press speculation.
Tonight, we have new exclusive revelations and reveal the complete story of this mysterious visitor, which now goes by a suitably exotic name, Oumuamua. To tell this detective story, I've come here, to Belfast, which has become the centre of research into this cosmic visitor, an object called Oumuamua. When we first saw it, all we knew was that it was small and moving fast, the first object from deep space ever to be seen passing through our solar system. And its sudden appearance raised a whole host of questions. What did it look like? How had it formed? What was it made of? And where had it come from?
To answer these questions, I'm going to piece together all the clues that scientists were able to extract from the small amount of data that they gathered as Oumuamua flashed through the solar system. This forensic analysis, including new exclusive revelations, will give us the most comprehensive picture yet of this extraordinary object. Our story starts in Hawaii in mid-October last year, when one of the biggest telescopes in the world spotted something unusual. Now this is the first picture taken of Oumuamua from the telescope in Hawaii. Looking at it, it's quite hard to spot, but it's actually this splodge here. Now you can tell it's moving really fast because the stars appear as points, whereas this is a blur across the screen. I called Karen Meach in Hawaii, who led the team that night to find out how the discovery was made. Hi Karen, nice to meet you and thank you for waking up so early.
Oh, no problem.
Now, can you take us through the night of the first observation?
Well, this was discovered by the Pan-STARRS telescope in Hawaii, which is conducting a NASA-funded search for near-Earth objects. And this particular night, on the 19th of October, one of the objects that was flagged had a very long streak, which meant it was moving quite fast.
So, what had you effectively discovered by then?
Well, at that point, people weren't sure, but as soon as some follow-up observations came in, one of the groups at the European Space Agency ground station reported that the orbit looked interesting. Namely, they said its shape didn't look circular, and it wasn't until a few more nights of data came in that we decided that this was definitively something from outside the solar system.
How did you feel when you found out that it was an extrasolar object coming from another solar system?
I actually sat there for a while just thinking about what it meant and getting more and more excited that this really is the first time we have something so close that's delivered from outside. The frustrating thing was that it was moving so fast. We only had a little over a week, during which time it was bright enough to actually do the experiments you'd like to do. So what that really meant was a team of people were working around the clock, and I ended up sleeping in the office for most of the week because we were putting in 18-hour workdays.
How do you go about naming these objects?
We thought it might be nice to have a Hawaiian name. And so the director suggested that we talk to a Hawaiian navigator and a Hawaiian linguistics expert on the Big Island. And they suggested a very nice name to us. It was Oumuamua, where the O means to reach out for, and mua means first or in advance of, and by duplicating that piece, it gives it emphasis in Hawaiian. So the intent of their definition was that this is a scout or distant messenger sent out from our beginnings to reach out to us or build connections with us. So we thought it was a very appropriate name.
Thank you so much, Karen. It's a fascinating story, and I'm looking forward to finding out more.
Well, thank you.
Karen's discovery caught the imagination of scientists around the world. First indications were that Oumuamua was just a few hundred meters across and was travelling at over 50 kilometers per second. But the big story was about its origins. Within days, scientists had gathered enough data to start working out the trajectory of Oumuamua. Now, initially they assumed that it was an elliptical orbit. But just days later, they realised it wasn't an orbit at all. It was actually open. Now, this flagged up all sorts of questions, because it meant that Oumuamua didn't originate from within our solar system. More importantly, they'd only spotted it as it made its journey outward from the solar system. That meant they had a limited time to gather more data, to find out what it was like, how it was made, and where it had come from.
By late October, astronomers in Belfast and around the world were getting excited. Michelle Bannister's team were among the first to take on the quest to understand Oumuamua. They focused on what it looked like, what shape it was, and crucially, what colour. So you did what astronomers have always done, which is ask simple questions, like what colour is it? That can often tell us a lot.
Yeah, so we're seeing this object entirely with reflected sunlight. And so the colour that you get of the reflected surface tells you about potentially what the composition is.
And so what colour is it?
It's a touch redder than sunlight, but kind of pinky. However, you wouldn't see that if you were to look at Oumuamua with your naked eye rather than with one of the world's biggest telescopes. Because when it reflects the sun's light, it's reflecting it back at almost the same colour as the sun, just a bit redder in the infrared part of the spectrum.
This colour, a hint of pink or red, especially noticeable in the infrared, is reminiscent of some objects in our own solar system.
It could actually be a little cousin of one of the objects that you see in the populations known as Jupiter Trojans, which orbit out near Jupiter.
So another thing your observations showed was that the brightness of the object was changing over time.
Yes, we observed for about 2 hours. So if I show you here, so this gives you some idea of how the brightness that we measured changed over time.
You've got this really quite dramatic dip here. It fades quite dramatically and
It
then
changes
recovers.
in brightness over a remarkable amount of contrast, and we weren't expecting that. That was great.
What do we think causes that variation?
Probably the shape of the object. So I have a way of showing you what effect shape is going to have on the brightness of an object
Okay.
over time. So here I have a sun.
Okay,
Here I have a turntable that is rotating an object over time.
okay.
So the camera is watching this object and it can't see the shape of the object directly. It's just going to see its brightness. And on the screen here, you see what the camera is measuring of how it sees this little object changing in brightness over time as it rotates. Now the sphere, you can see you don't get much change in brightness at all.
No.
Let's try this with something a bit stranger in shape.
Okay, I'll remove the sphere. There we go.
Instead put on this delightful potato asteroid here. Yep.
Fine.
And you can see what the camera is seeing as this point of light changes in brightness as it turns is when the short end is pointing towards the camera.
Like it is now.
You have minimum surface area being reflected the light, so it's dimmest. And when it turns round and the whole side of this object is being illuminated, it's the brightest to the camera, and so you see this brightness peak.
And what do you find? What shape is Oumuamua?
It's actually got to be even more elongated than this little potato. This is 3:1. Oumuamua has to be at least 5:1, maybe
Wow.
even a bit longer.
But this is the thing, when I saw this result from all this hard work of astronomers scrambling to telescopes, it seems to me very unlikely that the first interstellar visitor would be this unusual. Is that something that disturbs you, or does this make sense if you've been thinking about these things?
The shape is a bit unusual, but that the colour is so much like what we see in our own solar system, there's a kinship there. It tells you that something that formed around a different star and something that formed around our own star have a lot of similarity in their surface.
It's a very deep thought, that. It's sort of a poetic, it's scientific, but it's poetic as well, that there is this relationship to something that came from so far away.
Yeah, we're finally getting to touch something that's from another solar system that's larger than a grain of dust.
Within days of being spotted, detailed information about Oumuamua was coming in. From Michel's light analysis, a shape was proposed. It was thought to be an elongated cigar shape, 100 to 400 meters in length. The ratio of length to width was thought to lie between 10 to 1 and 5 to 1. And although it was dark, it seemed to have a touch of pink or red. By the end of November, the strange shape and exotic nature of Oumuamua had led to some extraordinary speculations. Was Oumuamua an alien artifact? But it wasn't an entirely stupid question. Oumuamua was so strange that at this stage, almost anything seemed possible. So I met astrophysicist, an expert in the search for extraterrestrials, Duncan Forgan, to find out how scientists deal with the question of whether an object is natural or alien. So Duncan, all this very interesting data was coming through. What was the press's response to it?
It was a little bit frenzied, to be honest. There were a lot of stories about this idea that maybe this weird interstellar visitor was in fact an alien spacecraft coming to visit the Earth. But unfortunately, a lot of that stuff was very overbaked.
So how should scientists sort of treat these stories?
Well, I think it's important to make sure that when you're thinking about what is this new, interesting, weird thing, you make your list of what are natural explanations, and then right at the very bottom you put the alien's explanation.
Okay.
And you wait until you've exhausted all the natural explanations, and then when nothing else is left, Sherlock Holmes style, you come back to the alien's explanation. So one of the things that we did was to basically check if Oumuamua was a transmitter. So they wanted to see if it was emitting radio waves in the way that we would expect a radio transmitter built by an intelligent being to work. So they pointed the radio telescopes at Oumuamua and checked and found nothing.
So what would you have done if it was found out that Oumuamua was an alien artifact?
There are a list of protocols that people who are doing the search for intelligent life are supposed to follow, and what they call the post-detection protocol. So what do you do next? And so one of the things you need to do is A, check your answer, because if you get this wrong, it could be very embarrassing. Yes. So ask your colleagues to use a different instrument and try and do the same experiment. And if it comes out to be the same answer, then okay, you've got something there. And then get more and more people to check and make sure that your hypothesis has been validated. And then you go to United Nations and tell the Secretary General, by the way, there's alien life and it's coming towards us.
That's going to be an interesting email, isn't it?
Yep. And then you're supposed to tell the public at large.
Well, thank you so much. It's been fascinating.
Thank you.
In mid-December, the mysteries about Oumuamua were still mounting, and scientists were beginning to wonder just where it had come from. Michelle Bannister picks up the story. So this brings me to the next question I wanted to ask, which is, do we know where this asteroid, this body, came from? It seems to me you've seen it coming in, so can we trace it back?
That will be a work in progress. What we can do is say the arc that it took as it came into the solar system, if we extend that back and back and back for 100 million years, that's the better part of halfway around the galaxy as the sun's travelling.
Okay, so we've travelled a long way. This thing's been moving. It's complicated.
Yeah, you have to run the galaxy backwards in time and say, where were all the stars millions and millions of years ago? And then say, was Oumuamua close to one of these stars? And if it was, that's its last port of call. Now, that's not the same thing as saying that's where it's from, because the next star system that Oumuamua goes through, it'll look like it came from us.
That's true. People will aliens will trace it back and think it came from here. But people have tried to match this trajectory, to do this difficult calculation. How have they got on?
You can see it comes not close, but perhaps a little bit close to some stars. There's about 15 stars that are currently potential candidates that it could have come near in that time. But everything starts getting a little fuzzy because we don't actually know the positions of these stars particularly well. About 5 of them are in a group of stars loosely called the Local Association.
It's an amazing thought that it might be bouncing around, and of course it may encounter other stars in the future.
It has a long journey to go.
Michelle, thank you very much.
Thank you, Chris.
So tracking Oumuamua's orbit back through time and space has suggested that it might come from a group of stars that astronomers call the Local Association. You might think that the Local Association would be a nice, neat little cluster of stars in the night sky, but it isn't that simple. Although they all formed around the same place and at around the same time, just 100 million years ago, they have since spread out. Pete Lawrence explores this Local Association, starting by looking towards the southern part of the sky.
The Local Association is roughly in this direction here. Most of the stars in it are too dim to be able to be seen with the naked eye, but it does include one of my favourite open clusters, the Pleiades.
The Pleiades are some of our closest neighbours at a distance of 440 light-years. They're very distinctive, like a miniature plough. To locate them, find Orion in the southern sky and follow the line of the belt up and to the right, past Taurus and its distinctive V, and then continue the line. You should see a little huddle of beautiful blue-white stars.
These really are one of the highlights of the winter night sky, looking like rare jewels on black velvet. But binoculars or a telescope will show even more.
And photography reveals an exquisite blue nebula, visible because of light reflecting off of a cloud of dust that the stars are moving through.
Associations like this are often hundreds of light years across. For instance, there's another star in the association, which you can find by heading southeast from the Pleiades so that you're on the other side of Orion the Hunter, so a fair distance away. Here you're in the constellation of Monoceros the Unicorn. And there's a faint star there, which is a candidate for the origin of Oumuamua.
The star is called Ross 614. You'll need a telescope to see it, but to find it, go back to Orion and head south and east. Monoceros, or the Unicorn, is a group of fairly dim stars between Canis Major and Canis Minor, and Ross 614 is about halfway along his front leg.
And it's in this group. Oh, there it is.
It's just 13 light-years away and is a component in a red dwarf binary system.
And it's fascinating and really exciting to think that may be where Oumuamua came from.
By now, scientists had worked out quite a bit about Oumuamua. They knew its rough size, speed and colour. And if it did come from the Local Association, they knew its age too. 100 million years, when these stars were formed. But 2 big mysteries remained. What was it made of, and how was it formed? Back in Belfast, Chris met up with Alan Fitzsimmons, who started to investigate Oumuamua's composition. His team believed it was icy, like most small, distant objects. But all the images they collected told a different story. Because if it was icy, why didn't it have a tail?
And so you got those images back and you were expecting to see what? A comet with a nice tail, I guess.
That's right. This object passed pretty close to the sun, and so the ice is there, should have been heated, and we should have seen that material expanding away to form the atmosphere of the comet and the tail. But there was nothing like that. It looked like an asteroid, and so we're thinking, what is this thing?
What did you do next?
Well, the important thing then was to figure out how this object was reflecting light, because that could give us a clue to what it was made of. To do that, we needed to get spectroscopy of the object.
So what did the spectrum show?
Well, we saw the signature of carbon.
Carbon?
Yeah. Now, when we think of an icy comet, we think of something that's mostly made of water ice, although there may be some carbon monoxide and carbon dioxide. This is an object that could have been out there between the stars for millions or billions of years. And so it's been sitting out there, and during that time it's been affected by the cosmic rays, high energy particles that fill our galaxy.
Okay, so it's the cosmic rays that might have changed the surface. What would they have done to it?
They take those ices on the surface, and in particular they take the carbon, and the carbon rearranges itself to form new molecules and new compounds.
And so what does that look like? How can we see what's happening?
But I can explain using this demo now.
Okay.
Basically a meringue, egg whites and sugar, okay? And we can add some energy. Now, we're not going to use cosmic rays, we're going to use a little blowtorch here.
Well,
so
safety first.
Safety first, indeed.
I do this every time I cook, you know. Very sensible. Okay. There we go.
And now, if we add energy to that, we'll see a chemical transformation to a different substance.
It's a very different material on the surface, with the meringue intact inside. Now, look, this is great cooking, but what's this got to do with an interstellar asteroid or interstellar comet?
Well, instead of egg whites, of course, and sugar, we have ice, we believe, that we start off with. And instead of a blowtorch, we have energy deposited on the surface by cosmic rays.
But only on the surface?
That's right. Now, over about 100 million years, this chemical transformation can go down about 0.5 meter or so. Within that depth, we could still have ice there. And the important thing is that this not only changes the surface properties in how it reflects light, this new crust of carbon-based material also insulates the interior.
So it locks in, perhaps, the ice that's still there?
That's right, and when we do the calculations, we find that even though Oumuamua passed within the orbit of Mercury, passed very close to the Sun, that heat from the Sun could not have penetrated within more than 0.5 meter, so the ice would have remained locked up, and that explains why we didn't see a comet. We saw something that looked initially like an asteroid.
Well, we'll look forward to hearing about whatever comes next. Alan, thank you very much.
Thank you.
By Christmas, scientists had a pretty good understanding what Oumuamua was made of. But then came a new and exciting discovery, revealed tonight for the very first time. A powerful new theory started to emerge, based on a detailed analysis of the light reflected off Oumuamua. It suggested not just how it was formed, but also where it came from. To find out more, Chris met lead scientist on this new research, Wes Fraser.
So Wes, taking a close look at this thing, it turns out to be even more complicated than we thought. What's going on?
Well, I was weirded out by the fact that no one publishing all of these papers that are coming out of Oumuamua could actually determine how quickly it was rotating. And so one Friday morning, I just thought, okay, I'm just going to pull all of this together and see what I can see. Now that we've got many days worth of observations, surely we can put all of these data together and just figure out how quickly this thing is spinning.
Wes's new investigation compares the light we might expect from a spinning object, shown with the dotted line, with the data that Wes actually gathered.
So if you look at the plot here, it works in some places, but it completely fails in others where the curve is low. the data are high.
Yeah, look, down here in day 5, it's way off.
Yes,
or
exactly.
Even in the first couple of days,
Yep.
there's something odd going on.
It was exactly the comparison between night 2 and night 5 that really, there's something weird going on here.
Okay.
And so we started to look at it a little bit, and it was very clear that, in fact, this thing is tumbling.
So what do you mean by tumbling?
Tumbling is an unusual state of rotation. We can demonstrate this with a simple ping pong paddle. And so when we throw it like this, just spins on a single axis, and it remains that way. But when we throw it like this, it immediately enters tumbling. It spins like this at the start, but then quickly starts to wobble around chaotically. And that's what we call tumbling.
This thing's been traveling in space for a long time. How does it end up tumbling like this?
We think it was due to a collision. And so at some early stage of its life, it was just spinning normally like everything else, and then it suffered a collision that would impart enough energy on one particular spot in such a way as to then be confused in how it spins.
And so where would that have happened? Out in empty space?
No, so we can pretty safely assume that the collision that caused this thing to tumble was in its original stellar system before it got kicked out.
So this thing's carrying information about the early days of a different solar system.
In a way, yeah. It's hard to know if it was during planet formation or after the planet formation process. Certainly more collisions happened while planets are growing than afterwards, so that's a very good guess.
It now seems that Wes's result may tell us something profound. Oumuamua could be a relic from the formation of another solar system.
There is a chance that this tumbling occurred while planets were forming. And so this is actually a moderately violent process. So you can produce rocks and boulders and pebbles this way, but eventually you do produce the planets in the process. At that point, those collisions become violent and very destructive. This may very well be where Oumuamua's shape has come from. It's most likely where its tumbling has come from as well. And we do know that objects are kicked out of our solar system as well. They have been and continue to do so. And so while this is a bit of space that has come its way to us, we are of course sending bits of ourselves naturally to other places as well in a similar way.
You make it sound like the galaxy's full of these things.
Must be. Very, very much so. Yes.
So how come this is the first one we've seen? How many more are there that we're missing?
Our best guess at the moment, and this is pretty uncertain because we've only ever seen one, but our best guess is at least within our own solar system, there are about 10,000 of these currently passing within the orbit of Neptune.
There are 10,000 of these.
That's right.
Going through the solar system
That's
today.
Right. Today,
not
right
this year.
now.
Not
Yep.
in the. So why don't you see them?
For every one of those that we see, there's 10 or 100 that we miss, and that's just because of the fact that they're moving. And so it was a fantastic job of the discoverers to find this thing. It's a fantastic discovery.
Well, lots more to look forward
Yes,
to,
indeed.
and it will be intriguing to find out whether this one is particularly unusual.
That's right.
Wes, thank you very much.
Thank you.
The discovery of Oumuamua has been one of the great scientific stories of the last 12 months. This is our first deep space object, and this is now the most complete picture we have of Oumuamua. It's now suggested that Oumuamua's origins lay in the chaos of planetary formation. Around a distant star, perhaps 100 million years ago.
That's it from Belfast for this month, and we're taking a break next month, but we'll be back in April. In the meantime, don't forget to check out our website for Pete's Star Guide and for our special weekly weather forecast. And of course, get outside and get looking up. Good night.
Italian film drama next tonight. It's Mia Madre here on BBC4.